Hello and welcome everyone. Welcome again. I'm back again with the new solution for problem of the day. My name is Dalsaniya, and how are you guys? Can I know if I am clearly audible? Just write down. Hi Rishit. Hi. Okay, yeah, I was aware about that. Okay, sorry. So, were you guys able to solve today's problem of the day? Yes or no in the chat box? I guess the problem of the day was very easy. अरे इतनी जल्दी क्यों आ गए भैया 3 बजे के बाद आते हैं आप ठीक है सो बेसिकली सॉल्यूशन अभी प्रोवाइड करते हैं एट 12 a.m. right? So without any further delay, let's start the session. I'll be sharing my screen. Just give me a minute. Okay. Just write down yes in the chat box if the screen is properly visible and everything is fine. Okay, I guess everything is going good. So, what about today's problem of the day? How many of you are able to solve it? The question is not that much difficult and it is very famous kind of question. If you have like done arrays and if you have done matrix, then you might have encountered this question, right? Okay. So the name of the question is transpose of matrix and the difficulty level is very easy for this question. Okay. So basically if you have heard about transpose of matrix, I guess everyone who is from like engineering background, they might have studied it in 12th standard, right? So transpose of a matrix. So basically you will be given a matrix in the input and you have to find the transpose of the matrix. Okay, so that is the question. And if we have a look at the constraint, then the matrix which will be given to us will be a square matrix n cross n size, and according to the constraint it is given that the size can be as large as 10 to the power 3. So 10 to the power 3 rows and columns, and the elements can be from minus 10 to the power 9 to positive 10 to the power 9. Okay, so that was all about the constraint. So now what is transpose of a matrix? Let's recall that. So let's say I have given you a square matrix with this many elements in it. So basically write down what do you mean by transpose of a matrix. Anyone from the audience, what do you understand by transpose of a matrix? So let's say if this is the matrix A with size 4 cross 4, and if I want to find the transpose of a matrix, then basically A is equal to A transpose, where A transpose is something in which all the rows of A are now the columns in A transpose, and all the columns of matrix A becomes the rows in the transpose matrix, right? Rishit, you already gave the entire solution. Okay, so that's the actual thing which we will be doing further. But this is the meaning of transpose of a matrix, right? So I'll be converting the row into columns. So this is row 1, row 2, row 3, row 4, and this is column 1, column 2, column 3, and column 4 for this transpose matrix, right? And now if I want to convert it, I'll be converting the entire first row into first column. Okay, this is first row, R3, R4, and now this is what we are going to. So this is basically transpose of a matrix. I have converted each and every row into columns in the transpose matrix. So this is the meaning of transpose of a matrix. I hope it is clear to everyone the meaning, the recall. And you can observe in the output as well. This is what we are getting, right? So this is exactly what the question is trying to say. Is it clear? Write down yes or no in the chat box if this part is clear to everyone. Okay, I guess this is clear to everyone. So now how to solve this question? Okay, so let's start with the brute force approach. What can be the brute force approach? So basically, brute force approach, what do you think? What will be the brute force approach? Over here, I can observe in the transpose of matrix, I simply have to convert the rows into columns. Basically, the input matrix, take each and every row and convert them into columns. And now over here, if you observe that what is the return type of the function in which the arguments will be passed, you can observe the return type is void. So basically, somehow, whatever matrix you are given, whatever matrix is given to you in the input, you have to try to modify the elements in that input matrix itself. Okay, so basically you don't have to return any kind of matrix over here. You can observe in the function definition. So basically you have to modify the input matrix. So now how to achieve this? So basically over here I can clearly observe that if this is my input matrix, so basically in order to get this I need some extra space. So I can create one extra matrix and I'll be converting the transpose, and this transpose will be stored in, let's say, temporary matrix, which will be of same size. And now from there, you can again put all the elements in the input matrix. So basically from input matrix, with the help of nested loops, you can fill this temporary matrix that will be actually the transpose matrix. And now as we don't have any return type, I'll be filling all these values in the input matrix. Right, this can be our brute force approach. It's pretty much clear. Do you guys want me to uh, elaborate it more? Was it clear? If it was clear, just write down quickly a yes in the chat box if this is clear. Okay, so now first of all, if you want me to explain that what will be the brute force approach, I guess this is clear to everyone, and there's no requirement of basically writing the algorithm for brute force approach. I guess you guys are smart enough that a nested loop can be. Just let me give you an idea. So basically, you'll be needing two nested for loop. One that will be iterating over the number of rows, and one that will be iterating over the columns. That will be j, the inner for loop, right? And now while iterating over these elements, what you can do, you can keep a variable that will be iterating over each and every elements inside the transpose matrix. That means inside this temporary matrix. First of all, it will be standing over here. Let's say this is equivalent to, so basically j will be moving in this direction, right? It will be moving in column direction. And what else I need to keep? I'll be needing one more variable k that will be pointing to each and every, let's say, so basically this j will be iterating over rows in this matrix. Okay, so j over here you can observe j will be iterating over this many elements, right? And this j will be iterating over the rows in this transpose matrix. Okay, and the I value will be pointing to the column in which you are going to fill. So basically you have to reverse the I and j in transpose of matrix while iterating over the input matrix. Okay, so we have a message. Let's read it out. So Anshul says, "Hello sir, I start problem solving for today onward. Can you share me? I have some doubt. I have good knowledge of DSA as theory. How can I?" Okay, so Anshul, wait till the end of the session. I'll be quickly going through the approach of it, and we'll be having a good discussion on uh, your doubt. Okay. So that was the brute force approach. So let's analyze what will be the time and space complexity. Okay. So as you can observe, we need a temporary matrix, right? We need a temporary matrix. So the dimensions of this temporary matrix, let's say, will be n into n. And what is the dimension of this input matrix? It will also be n into n. So basically, and each and every element. So this will be our space complexity. Basically we are utilizing completely new matrix having same dimensions as the input matrix. So n into n will be our space complexity. And what about time complexity? So basically two iterations are required. One iteration that will be filling our temporary matrix, the other iteration will be filling all these values from temporary to input matrix. So two iterations are required. So I can say 2 n into n, or let's write it down as n into n. So this is our time and space complexity. We go of n into n. Is this clear? So this is our time and space complexity, right? Now I want to optimize it. So can I optimize the time complexity? Can I optimize the time complexity? Try to think. So you should focus, you should analyze that, can I optimize any of the thing from brute force approach? From the brute force approach, at least in order to fill the values, or at least in order to change each and every element, I need to iterate once over the input matrix, right? So this time complexity cannot be reduced down from an end to end, right? As we are working on matrix, each and every element needs to be encountered, so right. So this is some kind of like, you can't get rid of it, and it cannot be lower than an end to end. So what about space complexity? I can optimize my space complexity. Somehow I can do it in a better way instead of creating a temporary matrix. And with few of the observation, you can actually optimize the space complexity. So let's observe what are we doing in transpose of a matrix. Till now, was it clear? Yes or no in the chat box? A quick reply from everyone if this part was clear to you. Just write down yes or no in the chat box. So first of all, let's observe few things in the input and transpose matrix. Okay, thank you, Rishit, for the confirmation. So this is my transpose matrix and this is my input matrix, right? So now over here, if you observe carefully, this is my A 4 into 4 and this is my A transpose 4 into 4. See, if you observe carefully, this is, I'm converting rows into columns, right? So this is my primary diagonal of the matrix. You can observe the elements in the primary diagonal remain untouched. Can you observe this thing? The elements in the primary diagonal of the matrix remains untouched in both the input matrix as well as transpose matrix. There is no change. So what are we changing? So if you observe, I am changing this part, the upper triangular section of the matrix and the lower triangular section of the matrix. You can observe these elements are being modified. Okay. And if you observe carefully, if you know that I'm converting this row and keeping it as a column in this transpose matrix. So all these elements will be present over here, obviously. So these elements will be present over here and this element will also be present over here. So similarly, if this is happening, then the same thing will be taking place for the lower triangular matrix, right? Same thing will be happening for both the triangular matrix, for both the triangular section. So now, basically, if you observe carefully, basically we are just swapping the upper and lower triangular section of the matrix. Basically, we are simply rotating the matrix along the primary diagonal in this direction. And let's say if you observe from this section, and this is the primary diagonal of the matrix, and if you're looking at the primary diagonal, then you are rotating in the clockwise direction. See, the upper triangular section will be at the lower part and the lower will be at the upper part, right? Is this observation making sense to you guys? Yes or no in the chat box? Is it making sense that I am rotating the entire matrix along the primary diagonal in clockwise direction? A quick reply from everyone, like yes or no in the chat box, then we'll be moving ahead. So basically now this observation was clear. So now how to, like, somehow I need to implement this part, right? So what I can do from this observation, if you observe this part, see over here, this element, if you swap this and this element, that is the first element of both the triangular section, this element, then you can observe they are actually being swapped in the transpose of matrix, right? So similarly to this and this element and this element and this element, and which element, 2 will be shifted, right? And I have over here 3 will be present, right? So basically over here this 4 and 2 will be swapped, and this 4 and 3 will be swapped. So elements in this manner are being swapped. the corner elements in this manner, and this element will be swapped with this. You can observe over here 2 and 3 are being swapped. This 3 and over here you can observe 1 is being swapped, right? This is 1 and 3, and this 3 and 1. So basically you need to swap elements with what? So now I have observed this thing that I simply need to swap two elements, in the one from the upper triangular section and other from the lower triangular section, right? So how will I do that thing? How will I swap the elements? So first of all, I need indexes of each and every element in order to observe, right? That which indexes are being affected. So let me note down the indexes. So this will be 0, 1, 2, 3. This will be 0, 1, 2, and 3. Similarly, 0, 1, 2, 3, and 0, 1, 2, and 3. So now you can observe the element present over here. This element, it is present at index 1, it is present at index what? 0 comma 1. This element is and which element is being swapped with? It is being swapped with 1 comma 0. It is being swapped with 1 comma 0, and this element will be swapped with this element. So 0 comma 2 will be swapped with 2 comma 0. Over here you can observe this 0 comma 3 will be swapped with 3 comma 0. 0 comma 3 and 3 comma 0. You can observe this element and this element. Over here it is 1 and 4. Over here you can observe 4 and 1, right? So this element and this element, that is element at 1 comma 3 and 3 comma 1. 1 comma 3 and 3 comma 1. So if I write down, if I call the row as I and if I call the column as j, you can observe this will be your j and I. So basically over here in the input matrix, if I am saying that if I want to swap two elements, the element 1 is present, let's say in the input matrix it is present at a of I comma j, row and column is I and j, then this element will be present inside the transpose matrix. Let's say this is I dash and this is j dash. So basically the swapping will take place between a of j and a of I, and this element will be inside my transpose of the matrix. Okay, so I need to swap two elements, a of I comma j and a of j comma I, and that can be done. I simply need to iterate. I don't need to iterate over the entire matrix. See, if you iterate over each and every element, no. So first of all, swapping will be done for this many elements. So this many elements will be swapped, right? This many elements will be swapped. So now, if you will encounter this element again, no, again you will be swapping these two elements. So you don't need to iterate over every element and swap I comma j with j comma I. You simply need to target the upper triangular section or lower triangular section, either of it. Okay, because if you will work on both the triangular section, that means you are redoing the swapping. Okay, so the swapping will be reversed again and all the elements will be again at its original position, right? I don't want that. I simply need to target the upper triangular section and I'll be iterating over these elements and I'll be swapping with the j comma ith element. So first of all, I need to see how to iterate over the upper triangular section. If you observe the I comma I, let's say 0 comma 0 will be swapped with which element? It will be swapped with 0 comma 0, 1 comma 1 with 1 comma 1. So you can start iteration over here. How many rows do you need to iterate? You need to iterate only n minus 1. Let's say n is equal to what? N is equal to 4. Then you need to iterate over only 3 columns. That is 0, 1 and 2. That is 3 rows, right? And this will be your value of I, the outer for loop. And for the inner loop, you can start the iteration from which element? You can observe, you can start the iteration from the first element. That means the first element from the primary diagonal, that is from 0. For the first row, when I is equal to 0, you can start the iteration from 0th element. When I is equal to 1, you can start the iteration from element 1 in the column. And when I is equal to 2, you can start the iteration from element 2 in the column, right? I mean the element present at the column number 2. So just let me write down the algorithm and this will be making more sense. Till now, any doubt in any of the part, just write down, just post down the doubt if you have any doubt. Just to give me a minute. So this question was kind of easy. It's not that difficult. I do understand. So I need the iteration. So I'll be iterating from I is equal to 0 to I is lesser than n. All the rows. You can iterate over all the rows, or you can iterate over n minus 1 rows as well. Okay, so let's say if I'm iterating over all the rows, it won't make any kind of difference, because the inner for loop, will start from j is equal to I plus 1. You can start from I plus 1, or you can start from I itself. When I is equal to 0, the element that will be the column which will be targeting will be zeroth column. When I is equal to 1, you will be starting the iteration from column number 1, and when I is equal to 2, you will be starting the iteration from column number 2. So the inner for loop also can start from j is equal to I, or you can start from j is equal to I plus 1 to j is lesser than what? It is lesser than n. And inside this, you simply need to swap a of I comma j and a of j comma I, and this is the entire logic. Can we iterate from the element after the principal diagonal element? Because swapping principal diagonal elements is not useful. Yes, you can start from the next element after principal diagonal as well. Okay, you can start, but it will be like, you will be, this code will be more cleaner than if you start from principal diagonal. Over here you can start from j is equal to I plus 1. You can start from you can keep this I lesser than n minus 1, but in order to make it more cleaner, and so you can start in this manner. Okay, any doubt till now? If you have any kind of doubt, just post it, or else I'll be coding the approach. Okay, clear. So now let's start the coding implementation. I'll be iterating from I is equal to 0 till I is lesser than n, and the inner for loop will be starting from j is equal to I to j is lesser than n, j plus plus. And I need to swap. In C++, you will be finding the function swap. Over here, I don't have that functionality in Java, so I'll be just using simple variables to swap. A of j I and a of j and I will be equivalent to m. And let's try to submit it. And now we can have a discussion. So I saw a doubt from Anshul. Okay, so compilation completed, and let's try to submit it. Okay, so the problem was successfully submitted, and if you want me to share this code, I can share it, but this is pretty much obvious, right? So I'm not sharing it in the chat box. So let's get back to Anshul, and let's first of all clear up what will be time and space complexity. You can observe the time and space complexity can be called as n into n, right? And space complexity will be constant in this case, because I'm not using anything that will be based on the input test case, right? Anything, no extra space. Okay, so that was it from my end. So now let's take what Anshul wrote down. So he said that hello sir, I start problem solving from today onward. Can you share me? I have some doubt. If doubt, I have good knowledge of DSA algorithm as theory. How can I do? Tell me some approach. Give me approach. So basically, I think you are trying to say that you have studied the theory of DSA, and now you are looking forward to practicing the questions, right? Is it so? So basically, after completion of theory, so uh, don't learn DS in such a manner that the theoretical part and the problem solving part should be a separate thing. It's not the case. Okay, so basically both of them uh, goes parallelly. Okay, so learn any of the DSA topic. Let's say if you are looking forward to learn binary trees, then do the theoretical section, and after completing the theoretical section, directly jump to problem solving. You can start basic algorithms, pre-order, in order, this traversal, that traversal, and different variation of those traversal. And after completing the basic algorithms, you should focus on standard algorithms. Okay, do all the standard questions of every topic, and then you can practice easy level questions which are not included in your standard question. So basically, first of all, complete the theory, and then go jump to the algorithmic part, and then from there do the standard problem solving, and then you can start with easy questions. So that is what I suggest is each and every student, that learn each and every topic of DS in this manner. Okay, so I hope have any topic list. You can, like, let's say, if you want to, if you're focusing for, let's say, interview, then you can focus on SD sheet, and there will be a good list available to everyone. Okay, so let's say if you so let me show you how you can do that thing. So let's say I want to study, let's say, cues. Okay, so I'm just showing you an example how you can do that thing, how you can study each and every topic. Let's say I want to study queue data structure. So I'll be looking for queues, and then I'll be writing geeks for geeks. So you'll be getting this page. So this says queue data structure, and over here you can observe there are many articles. And if you move forward, then you will be having a list of questions. Some must solve standard problems. I'm talking about this are the standard problems. Okay, so you can consider all the questions from easy to medium as a part of the standard, let's say, standard set of problems for any data structure. Okay, easy to medium, you can consider them as a standard set. Okay, and you can refer some of the hard problems as well. I'm not saying hard is not a part of standard set. There will be hard problems, but first of all try to clear easy medium and then move towards standard, and then afterwards you can practice any question of your choice. Okay, so you can do this, you can follow this for any topic of DSA. Okay, I hope Anshul, this makes your doubt very much clear. Okay, so that was it from my end. I hope you enjoyed this session. If you really like the session, then do like it and share it with your friends, and keep on solving problems each and every day. Maintain consistency, and that is what you will be. Uh, the result of consistency will be much far better than what you are experiencing now. Who is the comment of the day? Okay, so comment of the day in POTD. Okay, so let's start something like that. Okay, so I think for today I'll be giving you the comment of the day. Okay, Anshul. Although it was a good thing that was included from your end. Okay, so the basic thing I made clear by saying it was, do not think of theoretical part as a completely different section and problem solving as a different part. Okay, don't think in that manner. Okay, so thank you everyone and good night. Bye bye. Who is the comment of the day in POTD? I didn't get you. Who is the comment of the day? In POTD, comment of the day. Okay, so that was it from my end. Good night, everyone, and best of luck for the upcoming problem of the day. Thank you, everyone. Thank you. Bye bye.